Alright, so today is a lot like what we were doing. A lot like it. Except for this is called the rational zero theorem. You don't really need to write this down. I'll just explain it to you because I can see how that would look a little bit confusing. This is one of your first time seeing all of those math terms. So I'm going to explain what this is standing for. Let f of x equals a sub 0, a sub 1 to a sub n minus 2. Every time you see a, those are just standing for coefficients in front of your variables. Okay? A sub 0 is just telling us that's the first coefficient. So if your first coefficient is 5, that's standing for 5. X to the n, and then x to the n minus 1, and so on, all the way down to where we don't have x's. That's just showing that we have exponents that are in descending order, starting at the highest and working our way down until we have x to the second, x to the first, and then no x. So it's just a general form of a polynomial. Okay. So all these coefficients are integral coefficients. So we already know that we can look at our last term and use factors of the last term, right? We already know that. But we have to also take into consideration the first term. Okay? The reason why we have to take into consideration the first term is because let's say we had a quadratic factor down to this. 2x plus 1 times x minus 3. What would be your two solutions if this is what our quadratic factored down to? Yeah, this would give us a positive 3, and then 2x plus 1 would give us what? A negative 1/2. Now, if we only look at factors of our last term, would we be able to come up with a negative 1/2? Not necessarily, because here our last term was only a negative 3. Okay, and we would not have picked that out. So what we also have to do is we also have to consider the first number. Because these two first terms, when you multiplied it together, gave you a 2x squared. Your last terms gave you a minus 3. It doesn't really matter what your outside and inside are. It doesn't matter that says 5 there at all. So we not only are going to consider factors of the last term, so here it's the factors of the last term of 1 and 3, we're also going to consider factors of the first term, and we're going to consider all the factors of the last term divided by that. So here our factors of 3 are 1 and 3, but then we would also consider 1 divided by 2 and 3 divided by 2. And 1/2 was one of the solutions. So that's what this next line is telling us. This next line is saying plus or minus p over q are all of our possible factors, where p is a factor of our last number and q is a factor of our first number. Okay, so when we want to deal with all of our possible factors, we're going to try the factors of our last number, how we did yesterday. And in addition to that, we're going to have some fractions we can try. So I just want us to list all of our possible zeros. So when it says list all the possible zeros, that's listing all the possible factors that could work for this function. Okay? So we're not going to pay attention to whether or not they should be negative or positive. We're just going to list them. So we'll put plus and minus in front of all of them. So we're going to start off by looking at this last number 9. So for our function, f of x is equal to 2x cubed minus 11x squared plus 12x minus 9. So we're going to start by looking at 9, and we're going to list all the factors of 9. So what are all the factors of 9? So 1, 3, and 9. Okay? We did. It could be a positive or a negative. We didn't do the sign counts to figure out which one it is. But it could be either for all we know, so we're just going to leave it as plus or minus. Okay, what are all the factors of 2? 1 and 2, right? If we divide these all by 1, do we get any different numbers? No. Okay, so that means we're just going to divide them all by 2, which means we're just going to write plus or minus 1/2, plus or minus 3/2, and plus or minus 9/2. Those are all of our possible factors. So if, how come what?
Shouldn't there be plus or minus in front of the 1 and yeah, the 2?
In front of what?
The factors for 2. Wouldn't those be plus or minus 2?
Yeah, they would be. And so they're taken, these are not part of your solution, this 1 and 2 up here. These are just, we just listed the factors of 2 so that we knew what we would have to divide all those by. So we have to divide the 1, 3, and 9 all by 1, which gives us 1, 3, and 9 back, and all by 2, which gives us the 1/2, 3/2, and the 9/2. So what this is saying is if we wanted to solve this equation, same exact steps as yesterday, except for we could have some fractions that also would be solutions. So not only would we try the integers, we would also try some of the fractions out. Yes, this only happens if we have a coefficient in front of our first value, is when we'd have to look at the fractions. Number 2 does not look like the function I wanted it to be, so let me just fix it here. There we go, fixed. So number 2, f of x is equal to 5x cubed minus 9x squared minus x plus 105. So once again, we just want to list all the possible values that could be zeros of this function. So here we're going to have to start with 105. I probably could have picked a bigger number, but so yeah, calculators would be your friend on this. Okay, so
3 and 34.
All right, so 105. So we know it's definitely going to be 1 and 105, right? Is 2 going to be a factor of that? No, 3 is, though. 3 and what?
34.
Okay, so 3 and 34. 4 won't be. 5 and 21. Is 6? No, 6 shouldn't be because 2 isn't.
7 and 15.
7 is?
Yeah.
7 and 15? Oh, I ran out of space. I'll have to write it down there. I think that's all of them. Okay. 35, not 34. Thank you. There we go. So all the factors, we got plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 7, plus or minus 15, plus or minus 21, plus or minus 35, and plus or minus 105. So those are our factors of 105. Okay, now we want to take all of these and divide it by the factors of 5. So what are the factors of 5? Yeah, 1 and 5. If we divide these all by 1, are we going to get anything different? No, so we'll go through and divide them all by 5. So 1 divided by 5, so we can have plus or minus 1/5. 3 divided by 5, so plus or minus 3/5. What happens when we do 5 divided by 5? It's really 1, which we already have listed, so we don't have to list it again. Okay, 7 divided by 5, so plus or minus 7/5. What happens when we divide 15 by 5? It's 3, which is already listed, so we're not going to list it. 21 divided by 5. 35 divided by 5 is 7, already listed. And 105 divided by 5 is the 21, which is already listed, so we won't list it again. So here would be our possible factors.
What if you did list them again?
You're just being redundant. I mean, if you list it again, I'll probably write a little comment like you don't need to list it again. But make sense? Well, now we're going to take this idea and we're going to solve. So it's the same process that we did yesterday. It's just now we could have a possibility of some fractional answers. So find all zeros. f of x is equal to 2x to the fourth minus 13x cubed plus 23x squared minus 52x plus 60. These aren't random numbers. They're thoughtful numbers that will actually work. Yeah.
Do we have to find all those things first?
Yeah, well, so the process that we're going to do this is we're going to start off by starting with figuring out if we should try positive or negative numbers first. Okay, so move that up a little bit, and let's do the Descartes' rule of signs. So how many sign changes do we have in this function? 1, 2, 3. How many? 4. So that means we have 4, 2, or 0 positive. Okay, now we have to consider the negative ones. So x to the fourth would remain positive. What would happen to the x cubed? It would be positive. X squared? X? 60? Okay, so 0, negative. Oh. Which factors are we going to try for this one? Definitely positive. There's a possibility that none of them are positive, but since I'm giving you this problem, some of them are going to work. Okay? And now we want to figure out what factors we should be trying. So we want to consider 60, and it'd probably be a good idea to list all of our factors of 60. Okay, so we got 6 and 10. 1, 2, 3. Does 4 go in there? Does 4 go in there? Do you think so? 5, 6, 7, no. 8, no. 9, no. So 10's the next one. 5 times what gave you 60? 5 times 12. And then 4 times 15. 3 times 20. 2 times 30. And 1 times 60. We're not. We're kind of just putting this over to the side for our own benefit to look and see. And we also know that none of these are going to be negative. So we're just going to look at the positive versions of it. And what are some additional fractions that we could have here then if our first coefficient is 2? We could have, we could have a 1/2, 3 halves, 5 halves, and 15 halves. Okay, so these are the factors that we have to try. So we're going to set up synthetic and try them. And we are going to be smart about trying them. So, like, what would be a factor that you probably wouldn't start with here?
60.
Yeah, 60, probably not going to work. 30, probably not going to work. So we want to be smart when we try these. So we'll set up synthetics. We'll have 2, negative 13, 23, negative 52, and 60. Okay, we know we want to do positive, so let's just start with 1. Okay, synthetic division, so we drop down the 2. 2 times 1 is 2, add to negative 13, negative 11. Negative 11 times 1, negative 11, add to 23, 12. 12 times 1 is 12, add it to negative 52, negative 40. Yep. Negative 40 times 1, so negative 40, and add it to 60, 20. Okay, well that didn't work, but that's okay. So maybe we'll try 2 next. Drop down your 2. 2 times 2, 4, add it to your negative 13, negative 9. Negative 9 times 2, negative 18, add it to 23, 5. 5 times 2, 10, add it to negative 52, negative 42, Negative 42 times 2?
84.
Negative 84, right?
Well,
And then
because it's 2 or wait, no, it's
negative 84 added to 60? Negative 24. Ooh. What just happened between these two remainders? They went from a positive number to a negative number. So graphically, what just happened between the value 1 and the value 2? It went from a positive number to a negative number. Did it have to cross the x-axis between those two? Well, what number would be in between 1 and 2 up there?
1 point, or wait, 1.5.
A half. So maybe we should try a half and see if that works. No, a half isn't in between 1 and 2. What are you guys talking about? What? 3 halves. 3 halves is in between 1 and 2. So maybe we should try 3 halves. Okay? So does that make sense why we would try 3 halves here? Because 1 was positive, 2 was negative. We had to cross our zeros somewhere in between. So let's try 3 halves and see if that works. So drop down our 2. So 2 times 3 halves is 3 plus a negative 13, negative 10. Negative 10 times 3 halves, negative 15. Negative 15 plus 23, it's 8. 8 times 3 halves, 12 plus negative 52, negative 40. Negative 40 times 3 halves, negative 60. Added to 60, we get 0. So what's one of our solutions? 3 halves. Now I want to make sure that, not a half, 3 halves. I want to make sure everyone understands why we tried 3 halves here. Yes? Does it make sense? We went from a positive number to a negative number. We were going in order, so we knew that somewhere in between those two we had to have an answer. Yep, there's got to be definitely another positive because we have to get up to 2 positive. So now we now have this polynomial, right? So this is now a 2x cubed minus 10x squared plus 8x minus 40. So we're going to have to do synthetic again, but I'm going to suggest that you always look to see if you can simplify it anyhow. So in this case, is there a common factor we could take out? So let's take a 2 out. So if we take a 2 out, this then becomes x cubed minus 5x squared plus, okay. So now that we took a factor out, let's go up here and let's cross off factors that now will no longer work. So with this new function, do we have a coefficient out in front besides 1? Nope, so that means what tells us about all these halves? These no longer will work for us. How do we know that? Because now we no longer would have a factor out in front to divide by. We would just be divided by 1. We divided everything by 2. Over on the other side, 0 divided by 2 is 0, so we just took it out. Like we divided both sides of the equation by 2. I mean, you could write a 2 and then in parentheses if you want to, but no need.
Well, how'd you know that the halves won't work just because there's not a...
Yeah, the halves won't work because we no longer have a 2 in front of our first number here. Okay, so what else won't work up here? What else are not factors of 20 up here? Well, 60 and 30, right? What else isn't a factor of 20? 15, 12, 6, 3. And we already tried 1 and 2, and did 1 and 2 work? Nope, they didn't work, so I'm going to cross those off as well. So we have 4, 5, 10, and 20 left to try, and one of those should work.
How'd you know to use the 20 to base that off?
Because 20 is now our last number. Does that make sense?
And we just don't have a front number, so that's why...
Right, and we don't have a front number, so we no longer have to think about the halves. So let's do synthetic now with this. So we have 1, negative 5, 4, and negative 20. Out of 4, 5, 10, and 20, which one do you guys think will work? Yes, Joshua. Our last number is now what? 20. So it's got to be a factor of 20. Are any of those factors of 20, or is 15 a factor of 20? Nope, 12 is not a factor of 20 either. So we went up to our original list here, and we crossed off everything that would not be a factor of 20. Because it's not going to work anymore, because now our last number is 20. All of our final numbers would have to multiply to give us that 20. So we were left with 4, 5, 10, and 20. So which of those would you like to try? 4. Okay. So let's give 4 a shot. So we'll drop down our 1. 1 times 4 is 4 plus a negative 5. Negative 1. Negative 1 times 4. Negative 4 plus a 4. 0. So is this going to work? No, this won't work. 4 times 0 is 0. So that gave us a negative 20. So now which one should we try? 5. All right, let's try the 5. So we drop the 1 down. 1 times 5. 5 plus a negative 5. 0. 0 times 5 is 0. Plus 4 is 4. 5 times 4 is 20. Is 0. So that means 5 was another solution for us. And what quadratic are we left with here? Yep, x squared plus 4. All right, if we have x squared plus 4, we want to get our remaining 2 solutions. So we'd go, okay, x squared plus 4 should equal 0. So what does x squared have to equal? Negative 4. Take the square root, and what do we get?
2 squared.
Plus or minus 2i. Yep. So here would be our 4 solutions.
Why did you say that x squared had to equal negative 4?
We subtracted the 4 over here to get the x squared alone.
Okay.
You can go. Okay, so let's just recap this process. I want to make sure you guys understand. So we first looked at our original function, and we decided whether we were going to have positive answers or negative answers. In this case, we decided we had to have positive because that's the only thing we had. So up here, we decided we needed to have positive values. Once we decided that, we listed all the factors of 60 out. Okay? So here were all of our factors of 60, and then we did all of the factors of 60 divided by 2. We went through and we started with positive 1. We got a remainder of 20. We did positive 2. We got a remainder of negative 24. So we knew somewhere in between that 20 and that negative 24, we crossed the x-axis. So we picked our value out that was in between 1 and 2 of our possible factors, and that was 3/2. Okay, so we picked 3/2 out. And now we got the remainder of 0. So we wrote down our new polynomial, the 2x cubed minus 10x squared plus 8x minus 40. And we saw that it had a greatest common factor of 2, so we pulled the 2 out. You can think of the 2 as being in front of it or as divided to the other side. It doesn't matter. The 2 is no longer there. Now our last term is 20. So we went up to our factors that we had, and anything that was not a factor of 20 we could cross off because it's no longer going to work. We also could cross off the 1 and the 2 because we already tried those and they didn't work. We noticed that we did not have a 2 coefficient anymore, so we also were able to eliminate the rest of the fractions as possibilities. So we were left with 4, 5, 10, and 20. We tried 4, it didn't work. We tried 5, it did work. We have our quadratic. This we didn't have to use the quadratic formula for because we could just solve it. Everyone understand all that? Do you want to do another example or you just want to start trying them?
I just want to start trying.
Start trying them?